Part 3 of our functions videos. We are going to be looking at the third standard that we need to know for functions. So this standard asks us to interpret the equation y equals mx plus b as defining a linear graph is a straight line. So what we're going to be able to do is we're going to be able to recognize a linear function from a graph and an equation today. So let's go ahead and get started. So our task is going to be able to decide which of the following points on the graph are on the graph of the function y equals 2x plus 1. So they give us a list of points here. And this list of points, we are going to use, if I can get my pen tool working, this list of points we're going to use to define if these points are on the graph. We're not going to find 3 or more points. We're just going to look at these first few points and find if they're on the graph. Then what we're going to do is we're going to find several points that are on the graph of the function y equals 2x plus 1. And then we're going to compare these graphs. So let's go ahead and take on part A. It says, decide which of the following points are on the graph of the function y equals 2x plus 1. When they ask us to find out if a point is on the graph, we need to find out if the point makes the equation true. So if you think back to first semester, for a point to be on the graph, it has to make the equation true. So if I plug 0, 1 into y equals 2x plus 1, and both sides are equal, it means that equation is true. So if I plug my 0 in for x and my 1 in for y. So hopefully you remember that all ordered pairs are x comma y. So let's go ahead and test this out. I'm going to plug my 1 in for y and my 0 in for x, and I'm going to solve. So 1 is equal to 1, which means the point 0, 1 is on my graph. Let's go ahead and try the second one. So the second point is 2 comma 5. And I'm plugging it into that same equation. My x value gets plugged into the x. My y value gets plugged into my y. So 5 is equal to 2 times 2 plus 1. And before I solve these, it's probably best that you pause the video and try solving these yourself. So now that you've seen 2 examples, I want you to go ahead and try plugging in 1/2 comma 2 and 2 negative 1. We're going to eliminate these and see if those points are on the graph. So go ahead and pause here and test out the point 1/2 2 and the point 2 comma negative 1. All right, so hopefully you took some time to pause. We're going to go ahead and highlight where these go. So we're still looking at that equation y equals 2x plus 1. So my x value is 1/2, and that y value is 2. So I'm going to go ahead and plug in what I know. So 2 equals 2 times 1/2 plus 1. So y equals 2 times 1/2. Well, oops, sorry, not y. Let me go ahead and erase that. Should be a 2 there. Silly me. So 2 equals 2 times 1/2 is 1. And 1 plus 1 is 2, so 2 equals 2. That one checks out. And the last one, we're still plugging into that equation. So I'm going to use my handy dandy highlighter here. 2 is going in for x, and negative 1 is going in for y. So let's test this out. So negative 1 equals 2 times 2 plus 1. 2 times 2 is 4 plus 1. Uh-oh. -1 does not equal 5. So these 3 points are on the graph. Those 3 points are on the graph, but that fourth one is not. So let's go ahead and I'm going to actually snip these 3 points real quick. And we're going to move over to the graph. So you'll want to go 2 slides over, and we're going to graph these points and kind of check out what's going on here. So I'm going to graph 0, 1. So I go over 0, up 1, there's that point. Over 2, up 5, there's that point. And over 1/2, up 2. That's my 3 points. So what I'm going to do is I'm going to go ahead and draw a line through these points. And if you're struggling with what these points look like, you can always remember it's an elevator. So I'm going over 0, up 1, over 2, up 5, over 1/2, up 2. That's where I get those points from. So there's that line. I'm going to ask you to pause right here and think about this graph. Is this a linear function? All right, hopefully you thought about that, and yes, this is a linear function. This is a linear function. So now that we've understood that, we've graphed this, let's go to part B. It says find several points that are on the graph, and I keep doing that, I'm sorry. Find several points on the graph y equals 2x squared plus 1. When it asks us to find points, we actually need to create those points. So we know that if I come up with values for x, so I can use any values in the entire world for x, and if I plug those in, I could get a y value. So to find what y equals when x is -1, I'm going to plug that in. So 2 times, we're going to follow that PEMDAS, -1 squared is 1. So y equals 2 times 1, which is 2 plus 1. So y is equal to 3. I'm going to do the same thing with my 0. And again, I got those points just by making them up. You can use any points. So 0 squared is 0, so 2 times 0 plus 1. Anything times 0 is 0, so 0 plus 1 is 1. And my last one, y equals 2 times 1 squared plus 1. So what I'm doing, 1 squared is 1. What I'm doing is I am trying to find points on this graph. So the first one, they gave me points and they asked me to find out if they're on that line. And we figured out which ones were on the line and we graphed it. Now I'm doing reverse, where they give me the equation and they say come up with your own points. So what we're going to do is we're going to take these points over to our graph and we're going to plot them. So I'm going over -1 up 3, over 0 up 1, and over 1 up 3. And I'm going to make my shape here. And yes, I know that this should go through there, so let's try that again. All right, so that's about as good as I'm going to get it. So if you notice that this second graph, so this was y equals 2x squared plus 1, and this was y equals 2x plus 1. If you notice that this second graph, it is not linear. It is a function, but it's not linear. So the first one is a linear function. So that first one is a linear function, but the second one is not a linear function. It is a function, but it's not linear. All right, so let's go ahead and we're going to move on to these last two, which won't take us too long. It says select whether each function is linear or not linear. In order for something to be linear, it means that it has to be a straight line. So when I'm looking at y equals x divided by 2, I'm going to use Desmos to help me out. So if I go ahead and go to desmos.com and click the Start Graphing tool, I can plug in y equals x divided by 2, and you'll see this is linear. So for this box, I would check linear. Based off of what we saw here, I want you to think about this next one. So do you think this one would be linear? Y equals 2x cubed plus 1, linear or not linear? And what we're going to do is we're going to check this out in Desmos. So y equals, I believe it was 2x cubed plus 1. Whoa, look at that crazy graph. That is definitely not linear. So when we're talking about linear, if there's an exponent, you should automatically know that it's not going to be linear. So using that, let's look at these several functions that represent different savings accounts. Which ones are non-linear? You can use Desmos, or you could use what I said about exponents and try to figure this out. So pause here and check out these different graphs. All right, so hopefully you paused and maybe you used Desmos, maybe you didn't, but let's go ahead and check these out. So y equals 5.50x plus 7. That one is definitely linear. Definitely linear. See that graph? It's a linear function. Let's try the next one. Y equals 5.50 times 1.02 up x. We'll probably have to zoom this out, but whoa, that is non-linear. So we would want to check this one off because it's asking which one's non-linear. All right, so we've checked that one out. Let's go ahead and go to the next one. So y equals 0.5 times x up 2. Definitely not linear. Definitely not linear. So non-linear. Hopefully we can start seeing this pattern. We should know that this one is linear. There's no square, there's no cube, there's nothing happening. So that one would be linear, and this last one would be non-linear because of that square. So this whole entire standard is trying to get you to understand if something is linear or not linear. So hopefully you can start thinking of some characteristics that you can use to describe these functions. All right, that is all for today. I hope you guys have a fabulous Wednesday.